Hello students. So in my previous lectures I was discussing about photovoltaic cell. So there I discussed about what is photovoltaic cell and what are the prerequisites for photovoltaic cell. That I have discussed the prerequisites that you need to know for better understanding of the working principle of photovoltaic cell. So I discussed about p-type semiconductor, n-type semiconductor, and then p-n junction, and then what will happen if light falls on the depletion region of p-n junction. These all things I have discussed in my previous lecture. So in this lecture I'll be discussing about the construction and working of photovoltaic cell. Now, since you might have become familiar with the prerequisites of photovoltaic cell, so now it won't be that difficult to understand the working principle. It will be same as my previous lecture. The working principle of photovoltaic cell is very similar to the process that I have discussed when light falls on the p-n junction. So let's start with the construction of photovoltaic cell. So this photovoltaic cell is basically a junction diode, although its construction is little bit different from conventional p-n junction diodes. Here a very thin p-type semiconductor, you can see this is the p-type semiconductor, this blue portion. So a very thin here a very thin layer of p-type semiconductor is grown on a relatively thicker n-type semiconductor. So here it is a n-type semiconductor and it is thicker. The p-type semiconductor layer is thinner as compared to the n-type semiconductor. So a very thin layer of p-type semiconductor is grown on a relatively thicker n-type semiconductor so that light can easily enter and reach the p-n junction. So whenever light will fall on this photovoltaic cell, since the p-type semiconductor is very thin, so light can easily enter the p-n junction. This is the p-n junction, this is p-type semiconductor, blue portion, this orange portion is n-type semiconductor, and this is the depletion region of p-n junction. So light can easily enter and reach the p-n junction. Then a few thin or you can say a few finer electrodes on the top of p-type semiconductor has been applied. As you can see, few finer electrodes has been applied. These are the electrodes, this thing. So few finer electrodes on the top of p-type semiconductor layer has been applied, and these electrodes do not obstruct light to reach the thin p-type layer. Just below the p-type layer there is p-n junction. As I have already discussed, there is a p-n junction just below the p-type layer, that is the interface of p-type semiconductor and n-type semiconductor, that is the p-n junction. So there is also a current collecting electrode at the bottom of n-type semiconductor. These are the collecting electrodes at the bottom of n-type semiconductor, and the entire assembly is then encapsulated by a thin glass to protect the solar cell from any mechanical shock or vibrations. So this was about the construction of photovoltaic cell. Moving ahead to the working principle of photovoltaic cell, what happens? So yes, the light photons, since this is the p-type semiconductor, this is the n-type semiconductor, here the light is falling on this photovoltaic cell, this is the solar radiations. So the light photons can easily enter in the p-n junction, this p-n junction, the light photons can easily enter in the p-n junction through very thin p-type layer. The light energy is in the form of photons. I told you by the quantum states of matter, light can be considered to be formed of photons having energy. So the light energy in the form of photons supplies sufficient energy to the junction to create a number of electron hole pairs. So after the light striking the p-n junction, or you can say the depletion region, after entering the thin p-type layer, again I am repeating, this light photons after crossing the thin p-type layer, it will reach the depletion region and it will create a number of electron hole pairs, as the principle I have discussed in my previous lecture also. So the free electrons in the depletion region can quickly come to the n site of the junction due to the potential barrier of the depletion region, that is negative ions in the p side. I told you this is the p type and this is the n type, and in the depletion region in the p side we have negative ions, and in the depletion region in the n side we have positive ions. So once the light photons after entering the p-type thin p-type layer and reaches the depletion region, these photons will strike the electrons and will form electron hole pair. So this electron hole pairs so formed in the depletion region, the free electrons in the depletion region can quickly come to the n side because of the negative ions of the depletion region, or you can say because of the potential barrier of the junction. Similarly, the holes in the depletion region can quickly come to the p-type side of the junction because of the positive ions in n side of the depletion region. So once the newly created free electrons come to the n side, it cannot further cross. Once the new electrons after coming to the n side, it cannot further cross the junction because of the potential barrier of the junction. Similarly, the newly created holes once come to the p side cannot further cross the junction because of same potential barrier of the junction. So as the concentration of electrons becomes higher in one side, that is n-type side of the junction, and concentration of holes become more in another side, that is p-type side of the junction, the p-n junction will behave like a small battery cell. So a voltage is set up which is known as photovoltage. So because of this extra electrons in the n type and extra electrons in the p type, why extra electrons and extra holes, sorry, again I'm repeating, because of the extra electrons in the n type and extra holes in the p type. Why extra electrons and holes? Because these electrons and holes have been formed in the depletion region, and because of the potential barrier of the depletion region, electrons have come to the n side, holes have gone to the p side. So extra electrons are present in the n side and extra holes in the p side, therefore a potential barrier, or you can say therefore a voltage is set up which is known as photovoltage. And if we connect a small load, like here a small load has been connected from p to n. So if we connect a small load across the junction, there will be a tiny current flowing through this wire. The voltage induced by the PV cell depends on the intensity of light incident on it, which means if more number of photons are striking the depletion region, more electron hole pairs will form, more collection of electrons in the n side and more collection of electrons in the p side, therefore the voltage induced by the p cell will be more. So the voltage induced by the p cell depends on the intensity of light incident on it. That's why the name is so called photovoltaic, that is because of their voltage producing capability. Photovoltaic has the voltage producing capability, that's why the name is photovoltaic. And this voltage producing capability is because of the light incident on it, that's why the term photo is there in the photovoltaic. Photo means light, voltaic means voltage. Photovoltaic, why the name it is? Because it is inducing a voltage because of the light falling on this photovoltaic cell. And now what are the materials used in the solar cell? The semiconductor materials like arsenide, indium, cadmium, silicon, selenium and gallium are used for making the PV cells, that is photovoltaic cells. Mostly silicon and selenium are used for making the cell. So this was all about the construction and working principle of photovoltaic cell. In my next lecture, I'll be discussing about the VI characteristic of photovoltaic cell. I'm ending this class here. Thank you.